Hi friends, how are you all? So in this lecture we will continue with our discussion on Venn diagram. Okay, in the last lecture we studied how to solve problem when we have the Venn diagram. Okay, but we need to study how to draw the Venn diagram. Okay, in this lecture we will discuss how to draw the Venn diagram. Okay, so conventions to draw the Venn diagram. And we will discuss an somewhat advanced questions which is given here. Okay, the details of the question are given here. Conventions. So the first convention is the U conventions. That is the universal set convention. Universal set will always be represented by a rectangle. Right. Universal set will always be represented by rectangle. Now the intersection convention, that is, if we have to draw A intersection B, then we will draw A like this, and A intersection B will have some common area. This part is called A intersection B. Okay, this is the intersection convention. So we will, if A and B are disjoint sets, how do we draw it in the Venn diagram? If A and B are disjoint, then A will be like this and B will be like this. Because there is nothing common between them, and therefore A and B are disjoint means there will be nothing common. That common part we saw in the last slide will not be there. So if the subset convention, that is, if A is a subset of B. What do you mean by A is a subset of B? All the elements of A will be elements of B. Okay. But all the elements of B need not be elements of A. So this will be the set B. And inside B we will draw the set A. Here we are showing that all the elements which are in A are in B. B includes A. That is what we are showing in the subset convention. So these are the basic conventions we need to follow when drawing a Venn diagram. Okay. Now we have already seen how to write elements in the Venn diagram. Okay. So we will discuss this question here. Let U be U be. We don't want to consider the elements of U now because it is not given. NA is equal to 6, NB is equal to 4. And one more thing is there. A is a subset of B. This is given, and we need to find N only C, and N only D. This is what we need to find. Okay. So A is a subset of B, NA is equal to 6, NB is equal to 14. So what we have to do here is, let me draw it again a bit more bigger diagram because you won't be able to understand if I draw in this. Okay. So now NA is equal to 6 and NB is equal to 14. This is our universal set U. And we are drawing A. A will be a set like this. A. And, or we can write A inside itself. Oh, I will draw a bigger figure for it. A. I told you the inner sets can be circles or ovals. There is no convention for that. Only thing, the universal set should be a rectangle or square. So NA is equal to 6, we are writing here. And NB is equal to 14, and A is a subset of B. Therefore B will include A. Okay. B will include A and B is 14. Okay, NB is 14. Let me write it this side also, because everything I prefer to write it on the left side. I'm sorry I write it on the, or I wrote it on the right. Write better in the left side, 6 and 14. And then we are given NC is 8. But before we go to NC, we need to see A intersection C and B intersection C. A intersection C is 1 and B intersection C is 5. So what will happen? There is something common between A and C. Therefore, C will be a set like this. Okay, this will be C. And NC will be how much? 8. And this thing we are writing it here because it is in the right side. Now, A intersection C is 1. So we will write this like this. A intersection C is this part and this is 1. 1. And B intersection C is 5. Do you think B intersection C is this para or part or this whole thing? It should be the whole, because B includes A. So anything that is included in A intersection C will also be included in B intersection C. So an A intersection C is what? 1. B intersection C is 5, means this portion is 5. So this portion will be 5 minus 1 is 4. Okay, this is B intersection C. Now C intersection D is 4. Okay, and ND is 7. And D has nothing common with A. So D can be like this. But D has something common with B and C. So D will be like this. D. And ND is 7. Right. ND is 7. Now, NC intersection D will be 4. Okay, NC intersection D will be 4, but NC intersection and D intersection B will only be 2. So this portion will be 2 and this portion will be 4. Now let us take one more thing. N B intersection C intersection D is equal to 1. So this portion will be 1 because it has B, it has C, it has D. This portion will be 1. Now, and C intersection D is 4. Therefore, this portion will be 3. Okay, 3. This portion will be 3. Okay, now let me change a small thing. Let us make NC as 10. Okay, because we need 10 in C. I mistakenly wrote NC is 10. Now D intersection D is 2. So D intersection D is 2 means this plus this will be 2. So this will be naturally 1. Now what we have to find is only C and only D, right? Only C and only D. Now NC is 8 and we have to minus all three. 4, 5, 8 and NC will only C will be 2. 7. 7 minus 1, 2, 3, 5. 7 minus 5 will be 2. So N only C and only D are both 2. So this is the answer we are getting. Okay. Let me make the universal set like this itself. N C only is equal to 2. N D only is equal to 2. Now, if we have to compute the same for B, it is actually possible. Do you know why? Because this whole portion, 14 minus 6 will be 8. This portion will be 8. Okay, so 8 minus all these things. So 8, 4, 5, 6. 8 minus 6 here will be 2. Right. And if you compute the same for A, 6 minus 1, this will be 5. So if they ask n b only, okay, then you should tell 2 because A is a different set in this question. But if n A or B only means not in C and not in D. It can be in A or it can be in B, means it will be 2 plus 5, 7. So this is actually an advanced question in your Venn diagram. Such things are very rare for class 11, but still I thought it would be better. So this is how you draw a Venn diagram for 4 sets. A, bigger one B, C and let us D. So this would be the thing for today. The next lecture we will start with a new topic. So till then, stay safe. Thank you.